Hello, everyone. We are quite on time, but I introduce my session, if it's ready, more or less, I hope. Yeah, timer started. Now we talk about the electrification of transport, road transport in a urban context. So we will try to analyze the trends and use cases that are happening in our cities in Europe. I personally come from Italy, where the baddest news on e-mobility policy always come from. So my colleagues in the board member are always satisfied because they are not the worst, you know. And but actually, a lot of cities are working hard in Italy too to electrify road transport. One bus out of 3 is full electric now in the registration. Also, distribution of goods with last mile solutions is quite slowly but electrifying with the effort of big operators like DHL, Amazon, you know them. And also the electrification of cars in the biggest cities in Italy is going quite well. So of course the urban context is the most favorable for sure, also because of the local policies that are helping the adoption of the electric vehicles. But it's also more complicated because of space. There's no space to install charging infrastructure. Because of time, it gets a lot of time to install the charging infrastructure and to find the available power. So today we will try to better understand how to rely and build up and implement a good infrastructure, a good layer of data and hardware to allow the fleets in the urban context to be completely electrified. So I invite Wolfgang Kalthoff of KEYSIGHT to talk about the trend and the technology development on charging infrastructures. Thank you, Wolfgang. Yes, please. Yeah.
Let's go. Okay, here's the clicker, right?
Yeah.
Okay, that's a good one. So, hello and welcome everybody from my side as well. My name is Wolfgang Kalthoff. I work in the business development department of KEYSIGHT Technologies, and there especially taking care with my team for our charging technology and grid edge test solutions. So the slide says it, testing the future of automotive technology. That is certainly our topic here in KEYSIGHT. I would like to lose a few words to the company. This year we actually have our 10th anniversary. However, it's actually a billion-dollar enterprise which has 100 years of history in business. So KEYSIGHT in 2014 was a spin-off of a company called Agilent. And Agilent was, again, a spin-off back then from HP. And so it all boils down to HP so far. We have multiple business segments, especially in automotive. We are very active. Again, I'm here to talk about our charging technology and grid edge test solutions. However, as long as the signal is electric or communication is electric, I'm quite sure that we can have the right solution for you to test and measure it. Okay, I would like to set the stage with this slide, where the charging station is the central interface between EV and the grid. You will see on the left side is the grid with the renewable energies and also battery storage systems. And on the right side, then you have the EV. And down below, you already can see a little bit of our equipment. Modular solution starts from the left. That's a grid emulator. It can simulate and emulate a good or bad grid, but also can support you with conformance testing to grid code compliance, grid communication compliance, or grid quality testing. In the middle, you see our charging technology test solution. This can actually emulate a charging station or an EV on a communication level, but also on power level. For the power, then on the right side, you see our battery emulator that then can emulate the car battery in various sizes. I would like to take you to a journey when actually we have started to test charging test solutions back then. And I would like to put the focus on the right side of the slide, because that's where it started. And back then we saw few connectors. On the top line you see the AC connectors, AC type 1 for US and Japan, AC type 2 for Europe, and GBT AC for Greater China. And for DC we had back then CCS DC type 2, CCS type 1 for US, type 2 for Europe, GBT DC for Greater China, and CHAdeMO for Japan. Meanwhile, we see the landscape is actually increasing. Especially in the US, that was exciting, that the NACS, or in today's name, SAE-J3400, that came to the market, and I think that is, meanwhile, for sure, will take over time the US market. Will not happen in Europe in the same manner, as this charging plug design is actually only supporting single-phase AC charging. Furthermore, we see the MCS, Megawatt Charging System. This is a new introduction for heavy-duty application. Should support currents up to 3,000 amps and voltage up to 1,250 volts. In future, there is an intermediate step that is currently in the rollout. However, also here, standardization is still work in progress. In Greater China, actually, there's also progress, parallel progress. There's a follow-up GBT standard, like the ones that was available ever since. However, there's a new one that should also address higher power, GBT 2015 plus or 2023. But also there's a parallel charging standard evolving that is CHAoG and Ultra CHAoG as well. In India, we see also new connectors coming to market. Unfortunately, also not a harmonized connector. Here is also industry competing to each other. And this should be then the charging standard for two-wheelers. As I said, unfortunately, will also probably be 2 different or 3 different connectors that will be available. When we compare that to the use case side, then back then we talked about V1G. That's also a new term to differentiate from real V2G, actually. And we had unidirectional charging, AC, PWM-based, and DC, most likely DIN-based, up to 15 kilowatts. If we compare that with the landscape today, then actually we see that the use cases increase quite rapidly. So starting on the top line, we today look also on bidirectional power transfer. We will soon look also in the European area to so-called vehicle-to-load or vehicle-to-home use cases. Already a few pilot projects are available, but this is unfortunately so far not yet standardized. MCS, as announced, that's a huge topic. Also super interesting, not only transportation on road, but also aviation, mining, ferry transfers, all of that will be electrified soon as well. Pantograph charging or automated contacting devices, such as underbody and side coupling solution, we will see soon as well. You might wonder, pantograph charging, well, that's reality already. Yes, you are right, but still not in a standardized, harmonized way. So there are pilot projects as well, and therefore it works already today. Wireless power transfer, basically same thing. Also technology is there. We have understood the technology. However, standardization still not yet fully harmonized. Okay. When we look on the left side, this is basically a new trend that we also see, that we now need to incorporate also grid-relevant aspects. And besides the complexity that increase because of additional connectors or additional features, use cases, and protocols, we also see on the grid side that, especially on an international, but also on a European level, we actually have quite a lot of work to do, especially when it comes to regulatory requirements, how to test it. Talking here about network code, or in the US it's called grid code, but also grid communication is a big topic, because if you envision that for example, a grid operator needs to shut down the grid because of maintenance, and a car is approaching a public charging station and wants to feed back, then there must be a safety measure that the grid operator can communicate to the connected car to avoid that this is, in this moment, now feeding back energy to the grid. Okay. In summary, 3 trends that we see in the market. So all this is really about higher power, faster charging. Big topic. You see below the charging standards just announced that address this topic. And second trend that we see is the rollout of plug and charge. Plug and charge is basically a feature of the ISO 15118 protocol that simplifies the authorization and billing process. It's self-explanatory, so you plug and charge, you haven't have to do anything else, so no need any longer for this pack of RFID cards to authorize, no need for credit card to bill, everything should run automatically. In addition, we see also a trend, and that is a good trend, and this is about certification of charging station. Also here, the current situation is that there is no mandatory regulatory in place that a charging station has to comply to certain standards. And this is basically missing. We are working in the vendor team of Charin as well and cooperate there to bring the next level of DCE VSE certification to market rather soon. But of course, we also need support that this is a mandatory requirement if you want to place charging station, and especially in the urban context. It's not important that the charging station is there. That is one thing, of course, but it's more important that the charging station that is there is working. Third trend, as mentioned, really feeding back energy to the grid. Big topic, enables a lot of use cases, or we heard already today in the panel discussions, stabilization of the grid with the renewables. That's, of course, a use case, but also for the end user of electric vehicles. A lot of opportunities open up when this is reality. Okay, to sum up with the challenges, interoperability and conformance, that's really key. We look at evolving standards, that is needed definitely. Evolving use cases, these all needs to be tested, and we need to standardize and harmonize on the test requirements. And then the interconnection with international power grids, also a very, very big topic, because here, big energy industry needs to talk to automotive industry. These industries really had not much to do before electric mobility, but they each have a bunch of requirements before, and now they need to harmonize and align these together. Okay, with this, I will hand it back to Francesco. Thank you so much.
Thank you very much, Wolfgang. Please take a seat. I will invite also the other speakers, Anthony Dupont, the director of e-mobility as SMEG, please. That basically it's our host also. Thank you, Anthony. And Wolfram Sparber, the director of the EURAC Research Center in Bozen. You've heard about it before. And thank you very much, guys. Thank you, Wolfgang, for the introduction. I start with you because I want to go better in to better emphasize the trend in technology development, especially. Are we going in the right direction? I mean, we are installing and implementing a lot of charging infrastructure with plugs, at least 800 volt. It's okay, I mean, or there will be a disruption, or there will be only wireless. There will be, especially in urban environment. What do you think we are going to go?
I do think that we are moving in the right direction. We see a lot of opportunities. However, I especially think we need to accelerate the things, and actually also, as I mentioned in my keynote speech, also to accelerate the certification and to have that also as a requirement. And as soon as we have that, I think then the overall EV charging experience should improve rather quickly.
Okay, so and do you think that the power of the installed chargers it's enough? I mean, we should go higher and higher for cars, for example, or
I think
it's okay.
Yeah, I think it will increase as well. So currently we still see a lot of 50 kilowatt installation, but we also, speaking about Germany, we also have already, meanwhile, on the Speedway, a lot of 350 kilowatt solution. We also see new technology where you have one set of power electronics that can give you 350 kilowatts, but you have multiple charging satellites. And of course, if the occupation is high, then you have to divide the power. But if the occupation is low, then you can charge faster.
Okay. And do you see some application in a urban environment, for example, for wireless charging? You mentioned wireless charging. You are testing it.
Absolutely.
Do you know some use case that can be interesting?
Absolutely. And I think also the technology will succeed not only in an urban but also in a home environment. But in an urban environment could, for example, be if you go to a public parking lot and you have a coil underneath your parking spot, then you simply do not have nothing to do. In best case, the car is authorizing, connecting, billing, everything from alone. And then you come back to your car and it's charged. In best case, you can even track the charging. And in even more best case, you can also say, oh, the energy price is high. I resell the energy that I have. So then maybe you can make a profit by it.
It's really interesting. And you talk about the new standards also of communication, plug and charge, the new way of payment. What the value added for the customers and also for CPOs? Why are we going there, and what do you see the best solution?
Yes, for the end user, it's actually more convenient like today. Today, you really have to have this pack of RFID cards with you to be sure that you can charge or authorize your charging session. That should be gone in future, but there's also still some way to go because we have different charging station manufacturers that also ramp up their technology at different speed, and therefore only a few charging stations may support this. But also here, Charen, for example, has launched a logo, one for the plug and charge, but also one for the conformance test. And we rather see soon on charging stations these two stickers. And I can only recommend for EV charging users then to select the charging station which has these logos, and then you are already in the next level of charging.
Let me say last question about technology trends and so on. You mentioned the MCS, no? The megawatt charging system. It's really interesting because it's quite new. And how do you see the application in the cities? Because finding megawatts is not easy from a network point of view.
Absolutely.
How do you see them? Where to put it? How many? It's more outside the cities or inside the cities. What do you see?
Yeah.
What's your view?
I believe it would be close to a speedway, maybe at a hub where you then really get the 1,500 or 3,000 amps. However, we will also see a transition period where the trucks probably will be equipped with CCS sockets as well as MCS sockets, simply to be very sure and flexible that you can charge everywhere where you go. And maybe at the destination spot, that can be a hub where the goods are loaded to smaller trucks. There could be also a good place for a charging station.
Yeah, I saw in China, this is just for fun, that they are building up trucks, electric trucks with 2 GBTs in order to charge them together with 2 different charging points at more or less 800 kilowatts. So finally, there's a unique standard. It's really interesting. Wolfram, I go to you. Your region, your region of reference, I mean, the Trentino Alto Adige is a particular region. It's quite advanced in the electric mobility because you started long time ago. And so you have a lot of experience also helping administration to deploy, to planify for planning. So I wanted to understand how did you help and what's your experience in planning a good electric network for so many customers, because at the end, the market share in Trentino Alto Adige is quite similar, not properly, but quite similar to the European one. And also you have a lot of tourists coming from abroad. So what's your experience and the projects you deployed?
Yeah, thank you very much. I might ask the audience then to share my slides so I can give a couple of more information about the Italian situation. But first, let's start with our region. Our region is a little bit a special region. As you know, we are a small region. We are an autonomous region. We are not many people, 550,000 people living there. Many tourists, a lot of hydropower. So the ways are short in order to talk to politicians, as you said, but as well in order to talk to utility, to talk to the grid operator, and to talk as well. We have some producers of charging stations, and that helped as well. Let's say, so we have an, let's say, yeah, I would say a framework which is favorable for doing that. And as being a high tourist area, we just have many tourists coming from Germany, coming from Netherlands, coming from Denmark, and they, yeah, they were looking for, they came with electric vehicles, the first Tesla Model S were the starting one, so the hotel started, we need infrastructure, otherwise we might lose a share of tourists. And that helped, I would say, in our area to speed the process up. I would say the South Tyrolians are maybe in average, yeah, they are not the poorest population in Italy, and they are sensible to the environmental topic as well, because our tourism lives on the environment, basically. It lives on nature, and therefore, yeah, it's somehow, I would say there's a certain sensibility of using it, but as well of trying to preserve it, and that helps in showing up. So
I was asking for, please, to have the slides to be shared.
So while my presentation is maybe speeding up, what I would like to share with the audience is basically, yeah, exactly, that one, thank you. It's basically a study that we did together with the
thank you very much, guys.
Italian E-Mobility Association, so I'm going fast. With regard to buses, we are talking here about the urban situation, and we did a study together with MOTUS-E and colleagues from Sustainable Bus in order to look at the electrification trends in local transport. I think this session and this topic is important because buses are moving all day, and they're moving all day in urban environments. So they are all day very close to us, to our kids, to our families, which are walking around on the road, and therefore electrifying these pieces of transport actually has a much bigger impact than electrifying a single car, which is usually parked most time of the day. It was an extensive study. I just want to focus on very few of all these slides. On the one hand, we see on the bus sector maybe a stronger growth trend than in other sectors of the mobility trend. And what you say, and we see, especially in Italy, a much higher share. So these are numbers of 2023. 2023 is a special year because Italy had a big bonus of the Piano Nazionale della Resilienza e Recovery, so the recovery plan. And as well, it spent quite a lot of money, much more than in the years before, on public transportation. You see the numbers in the blue box on the bottom. So basically last year, tenders went out for around 1.8 billion euros for new buses. As you mentioned, Francesco, more than 60% were actually electric buses. So that's a very good share. And we are talking about around 2,300 e-buses and 160 fuel cell buses. With on the map, you see a little bit of distribution and some main cities. And obviously, there are some, as you said, which are really ambitious. I would say the best example is Milan. Milan started several years ago to decide, okay, we want to go all in. So we are not doubting anymore. We're going to go all in. And we want to do that pathway within 2030. So 2030 onwards, only electric buses in our fleet. For Milan, we are talking about 1,300 electric buses, so it is a certain number of buses which had to be bought. And obviously it's a matter of, as we know, buying buses, but as well, yeah, changing infrastructure. And changing infrastructure for 1,300 buses, that means as well setting up several of the depots. We see here a couple of numbers, so every single depot is several megawatts, so 9 megawatts, 7 megawatts, 8 megawatts. And obviously that has to be found on the grids. It is a major investment, and you have to see, we are talking about standards, what kind of plug, how do we manage that in the most efficient way? What is the pressure on the grid, but what can be in future the service for the grid? So these are becoming basically from a grid, from an invisible point, they're becoming a major energy user.
Yeah,
so, you know, there's discussion as well, should logistic companies or bus companies be regarded in future as heavy industries with regard to energy consumption, because that is what's going to happen. But I think it's interesting. It's, again, as many things in our transition here, is a challenge, but it's an interesting one.
Yeah, thank you very much. I'm pretty proud of the report because we made it together, so thank you, Wolfram. Anthony, thank you for your experience, because we are here, so you can. We saw a lot of charging points. So
yes,
am I right? A lot of charging points here in Monaco, and you did that basically with so many others.
Yeah.
How much is it difficult to deploy here? I mean, because of spaces, because of power availability. Please just tell us about your experience.
So yeah, we wanted to share the example of electrifying transport in Monaco because, well, it's one of the most urban areas you can get. Yes, there's a crazy density, about the most dense cities in the world. And as you know, the Prince Albert II said this morning, there is also a strong will and leadership around decarbonation, with ambitious objectives of reaching carbon neutrality by 2050. So it's kind of the perfect lab for experimenting green urban transport. So we did several things, not by ourselves. SMEG is the Monaco utility, so our main activity is to both as DSO, so we operate the grid and we sell energy. So we are both supplier and distributor. And it was really our position of being the operator and making, for the Prince and for the government, making things happen. And to make things happen, there were three steps and three pillars. First, you need to switch from ICE to electric cars, so that goes with that thing. And Monaco is far from Norway, but among the most advanced countries in Europe. We're above 13% of electric vehicles in Monaco, so that's a good share. And we've had dozens of projects for electrifying special fleets. There is a project ongoing for electrifying buses. We are about 1/4 of buses in Monaco that are electric today, and all of them will be electric by 2030.
Yeah, I will ask something about buses, please. Just
okay, I go.
Just say on the charging infrastructure.
That was just a teaser for later. Then
usually I have to stop people talking, but you are too fast. So please,
okay.
On charging infrastructure.
So for charging infrastructure,
do you have AC and DC also?
Yeah.
I mean, what's the differentiation?
So both because of the density of Monaco and the high share of EVs, I think that Monaco has one of the densest charging infrastructure in the world, with 700 public charging points in 2 square kilometers. And most of it, you said that you saw some of our chargers walking around or driving in Monaco, but actually most of the charging points are underground, because that's where most of the car parks are. That's where the car park. So those are challenges, because it's more difficult to install chargers underground than above ground, with security issues. And we've been working and accompanying the Monaco authorities also to define the right balance between, of course, making car parks and underground car parks and underground charging as safe as possible, but also allowing to this infrastructure to be deployed. And so we've been accompanying the government, and we've also been accompanying residential buildings, because that's the other side of charging. You need to have public chargers, but you also want to be able to charge at home. In Monaco, there is no parking space outside of, again, underground car parks. And we've also accompanied building owners to implement chargers in their buildings. And so power availability is not an issue so much, because we have quite a strong grid in Monaco. The challenges are in going underground and making it in the safest way as possible.
Thank you very much, Anthony. I hope there are spaces outside the underground parking, because I parked my car outside, so I hope, I hope there will be. But anyway, Wolfgang, again to you. You just mentioned about vehicle green integration, so I would like to better understand if you have some examples, use cases that are studied with your customers, how it is going, the adoption, which are the biggest projects. Do you have any clue how much,
yes, sure.
Where are we going?
Sure. So in 2022, actually, the ISO 15118-20 protocol was released, and this is the protocol that introduces the feature bidirectional power transfer. And that is actually also now being tested, of course, but also before OEMs for EVSE, but also EV, of course, started already tested on a pilot project base. We already heard about the project in Utrecht, for example, from Hyundai, where there also was a cooperation. That was non-standardized protocols that was used, and meanwhile, the opportunity is there to use the standardized protocol since 2022. However, also here, when a standard is released, then there is also a lot of feedback coming in. For example, there's currently an addendum planned to also factor in the requirements for ACV2G that were not yet incorporated in the standard, and that needs to be added, of course, so that the grid operator can communicate to the car when it is connected to the public charging station. So that is definitely a test scenario. And on top of that, when a standard is released, the same group of people usually starts to develop the conformance tests. So standards says only this is the specification, and then there's a separate document usually that says, okay, this is how you test and verify that the implementation is according to specification. And this is currently in the works. We have the first batch available, and we also contribute in the ISO group to define these test cases, of course, with our experience and experts. But it takes simply time. And that is something that we do not have. But yeah, slowly but surely, we are reaching target.
And you're simulating some use case that is quite significant in terms of numbers of charging points to be controlled. I mean, in a vehicle grid integration perspective.
Yeah, we do not have, let's say, the insight of what the customer exactly testing. We basically provide the tools, or we get a request, can you get the tool? And of course, if you use multiple tools, you can simulate, for example, an occupation scenario of a charging park, and then by that also analyze, okay, what is the impact to the power grid?
Okay, thank you very much, Wolfgang. Wolfram. If you, I wanted to have your view also on the again a bus perspective, you know, and electrification. I think a study of yours was really interesting because you made a lot of work for the bus operator in Bolzano. In Bozen, the situation is quite strange because you have a lot of hills, downhill, and so on. So, how did you find the solution? How is what it was how it will go to electrify the fleet in terms? You need two buses, two electric buses for one diesel bus, or it's something that is.
No, I think, so on the one hand, the technicians, I would like if you can load up my presentation again. So we have in Bolzano as well, again, a bit of a special situation that we set up. So there was a tendency that we wanted to electrify transport quite early, so around 2010, and especially buses. So there was set up the first hydrogen charging station, and we were part of several European projects in the hydrogen field. I think there's no way for a fleet owner that he does a transition if he needs afterwards double the vehicles than he needed before, because he doesn't have the space, it's a cost issue, and so on and so forth. So it has to be one by one, and in my opinion, it will happen only one by one. We had in Bolzano the opportunity on the one hand to do monitoring of hydrogen buses and electric buses, and as well we did a detailed study on on suburban areas, especially mountain areas, which here in Monaco is basically not so different. And we expected actually in the study to see that hydrogen will win in difficult situations with driving up and down. What we underestimated is the effect of battery electric buses of recovery, which of regeneration, which hydrogen bus cannot do. And therefore, basically, even on these routes, it's basically the same play-off. And as we know, the efficiency of hydrogen buses is lower, and therefore, basically, hydrogen buses are just simply more expensive. So wherever you can go electric, you go electric. We have now still a mixed fleet of hydrogen, electric, and hybrid buses in our fleet. But I think the tendency is going towards more and more electric. What we see as a next big order to come, and I'm curious to see then the real use data, are electric buses with a hydrogen range extender, because some of our operators are still afraid of the distance which can be driven by the buses. But I would say that, at least for transitional phase, is an interesting one, because you basically drive electric, and if that is not enough, you have a fuel cell. On top, obviously, it's an expensive option. So that is a little bit the drawback. But there will some buses come, and yeah, we should have the possibility to monitor them as well and to publish that data as well.
Yeah, of course, you are evaluating the solution with the range extender, because Bolzano invested a lot also in hydrogen. So you have a sort of a local production of hydrogen, isn't it?
That is true. Nevertheless, obviously, the efficiency issue is a matter. So yeah. So if we produce hydrogen by hydropower, the hydropower is part of the electricity grid, and we want to use electricity as efficient as possible. And if we have a more efficient alternative and a less efficient alternative, so I think we should just use the more efficient alternative, which is clear. And as well on the electric side, we just see a much stronger mass effect of the cars on the one hand, but as well looking at the bus numbers we saw before, there are much more electric buses being sold, and therefore the price regression is going to be faster, battery regression is going to be faster. So I think basically, direct electric vehicles will do a very large part of the way.
In Boson, did you evaluate also the cost per kilometer with the operator? So it's not only efficiency, but also a matter
obviously, efficiency then translates to cost, and we had a look, as we didn't want to go into the private numbers of the operator, so we just took the public numbers of used kilograms of hydrogen on the public charging station, and public numbers of that time, average public charges in Italy. So we used, on the one hand, 13.8 euros per kilogram hours per kilogram of hydrogen, and on the other hand, 0.42 euros per kilowatt hours of electric charging. And taking that numbers and taking the real consumption of the buses, it turned out that the hydrogen bus cost per kilometer is 2.3 times higher than the electric bus. So it's in a relevant way higher, plus, as we know, hydrogen buses are higher. So that business case is really very difficult to work out right now.
Yeah. And how those buses are being charged in the situation of Bolzano?
Yeah. So basically, that is what was interesting with the CEO of the bus company at that time. She said, look, I prefer hydrogen buses because for me it's easier from the bus fleet management. In sense that she said people is used that they come back, park their bus, and then somebody else comes and charges it, or let's say refuels it and cleans it and definitely parks it. And with an electric bus, that I have to reorganize my whole depot, because every bus needs his plug where it is charged and so on. So therefore, for me, hydrogen is just easier. That was her point of view, which is obviously absolutely fair. And therefore, she pushed at that time, especially in the beginning, a lot for hydrogen. As well, there were several European projects which co-funded the acquisition and the utilization. And I must say, in a practical terms, so from a kilometer point of view, both technologies are reliable. So we cannot say that one just didn't work out. Both technologies worked out. It's mainly an economic issue and an efficiency issue.
Thank you very much. Anthony, let's go. I mean, besides car, okay. What I stopped you before, so I apologize. But how do you electrify the rest? I mean, trucks, buses. How it is going here in Monaco, the electrification of vehicles, not cars, not passenger cars?
Yes, so I mentioned already the electrification of buses. So the company operating bus lines in Monaco is switching slowly to electric buses. They did quite a few testing and benchmark before finding the right vehicles, because as in other areas in Monaco, you have specific geography with small streets and steep slopes. Sorry. And now they found the right long buses, short buses, etc. And they are implementing the switch that will go over the next 5 years. Looking at heavy-duty vehicles, actually we find that buses was the easy part. Because now there is quite a mature, as we said, market for reliable electric buses and the charging solutions that go with them. And so now it's just a matter of willing to change and having the financing, the transition. But the technology is there, the vehicles are there. The other project that was a bit more challenging was electrifying garbage trucks, actually. So for the same reasons as buses, but even more, we have a wide range of garbage trucks because they need to go in ever smaller streets in Monaco and drive even steeper slopes. And it was quite a challenge to find the right vehicles and reliable ones. So it took us about 3 years of testing and sending back trucks that didn't work out before finding the right ones. And as in buses, there was the challenge of charging them. So I completely understand the point of view of the operator. When you operate bus lines or when you operate a garbage collection activity, your objective is to have transport passengers or to collect the garbage, but you don't want the technology to impact your core business.
Yeah, of course.
And so the most interesting and the most challenging was also to have a full understanding of normal case operations, meaning each truck, what is their route and how many times they do it per day and how long will they stay in the depot for charging, but also accounting for worst case or degraded cases. That means imagining when you have one truck less or when you have special events in Monaco, such like the Formula 1, let's say, then for those days you also need to have the infrastructure and the vehicles to operate. So we analyze the business and the operational constraints and design the charging infrastructure that go with it. But that's, I think, the key when talking about this is making it frictionless and seamless for the core activity and for the core business and for the operators.
It's really interesting. What are the typical mission? I mean, the range that you needed for garbage trucks.
Actually, for garbage trucks, it was not
so
ultra
much.
high power. Yes,
Yeah.
we did a mix of AC and 50 kilowatt DC chargers. The analysis that I just mentioned showed that it was not needed to go higher.
This is super useful. Thank you very much. I think we all our CPOs in our association would envy you because there's no permitting for municipality, region, and then the state. It's all together. Maybe it's easier. Anyway, thank you very much, guys. I would like to make a more general question, just to follow the path of the other panels, if it's okay for you. How do you see 2025? I mean, in 2024, it was a bit depressed. I mean, the sentiment, because CO2 regulation probably was capping the market. The OEMs were waiting for 2025 targets to launch the new models. How do you see 2025? What do you expect from the next year on the electromobility market? Wolfgang, you go first, and then.
Okay, yeah. I hope that we continue to follow the path, that we do not see any shift out of targets, basically. So we should focus, and I loved also in the previous panel the shift towards the climate, because I think that is also something that we saw this year, that we have actually an issue that we're trying to solve by all of that. And I hope that we continue this path and cooperate closer together instead of competing, regardless on what level.
Yeah.
Yeah, in my opinion, I asked the technicians again if they can surely share my slides again, otherwise, yeah, for now.
Slides, guys, please. Maybe it's clear. Thank you.
Oh, thank you very much.
No, not that one.
Ones, the other ones.
Thank you very much.
Yeah, exactly. Perfect. So I answer first to your question, then I go a little bit further. So basically, I think 2025 atmosphere is gonna be better, especially because we are going to have more vehicles on the market on more different segments. And so I think that is a very important thing. Clients want to have a choice, and so they have more choice, maybe as well from brands, they are well known, so therefore they want to follow. What I would like to share with you very shortly is the impact of full electrification we have been talking about several times. We did a publication a couple of months ago on that topic based on a study which we did over the last 2 years, so all the details can be found online. It's open access, so you're welcome to do. And what we see going through that, I think, is what we discussed before. You have to go very deep in order to see all different segments. So basically what you see here is the utilization rate of passenger car, of buses, of light freight transport and heavy freight transport. You see very different curves, and you see as well that, for example, the cars are just standing still a lot of the time. So in different positions, but they're standing most of the time, while, for example, buses are traveling much more, and they're traveling in a flatter way over the day. Obviously, heavy-duty vehicles are traveling a lot, but they are traveling a lot in the morning, so their curve is different. And if we want to go look not only on 25, but 2030, 2040, and so on, we have to see it all. And we really wanted to go deep in order to understand how many of these vehicles do we have, what are the curves, and what is the impact going to look like. So we looked on the overall fleet, but then we broke it down again to our region, because there we just have a lot of data. The first scenario is an actual trend, 2030. The second one is an IPCC trend, 2030. And the last one is a full electrification of everything. And obviously, you see that the impact is going up. We are talking here about 250 megawatts of peak power. In our region, we have right now 680 megawatts of peak power, so it is relevant. But as well, what you can see, and here we went a little bit further, what happens if we go from a dump charging to a smart charging to a vehicle to grid? And obviously, you can see how, in this scenario, we assume that 50% of all vehicles will be able to do smart charging or vehicle to grid, as you stepwise can actually drive down the peaks by around 50%. But as well as you can obviously start working on when in South Tyrol is hydropower producing electricity, when do we export, when do we need the import, how can we reduce the imports, and how can we sustain the grid that we saw before. So from these studies, we get an overall electricity enhancement of 30%, which is something, it is a relevant number. In South Tyrol, that is a special situation. Nevertheless, we produce more or less double the electricity that we consume. So for our region, it's not an issue. But I would say in general in Europe, it's a number, but it's a number that we can manage if we just continuously expand solar, wind, and battery and other applications. So that's it.
Thank you very much. Anthony, how do you see the future of electromobility market, of course?
Yes, I'm pretty confident about the future. The speaker this morning from S&P mentioned that 2024 was probably just a bump in the road. I think I think that as a society, the road is clear. I mean, the direction and the goal of electrification is validated and confirmed and has been agreed upon. And yes, there will be bumps in the road, but the road is clear for everybody. Just to comment on the news, but I think that something encouraging is also the positions taken by various industry CEOs and that are much commented upon. But just to take two examples, the CEO of Stellantis, Carlos Tavares, has long been an opponent of electrified vehicles, and now he's the one supporting the, maintaining the carbon emissions reductions and the trajectory. Just another related topic, the CEO of Exxon is also asking Donald Trump not to change any environmental issues.
I still need to understand why.
Yeah, but I think that, OEMs and CPOs and energy utilities and everybody as a society and policymakers, we have laid the road, and it's too late to go back or to change direction. So there will be bumps in the road, but we'll get there.
Thank you very much for this message of optimism. I really need it, when now I come back to Rome and new bad news will be on the newspaper tomorrow. Anyway, we have some time for some questions if you are interested. So we left just one there. Hey. There, right? Thank you very much.
Yeah, I am Karima Boukir from Enedis, from France. Yeah.
Yeah.
My question is for Anthony. I was wondering whether your buses depot are charging by night, for instance, or midday to synchronize with the local PV generation, for instance.
No, so I'm not an expert of buses charging, because this is operated by the Monaco operating company for buses, but they have done the same thing I mentioned for garbage trucks, meaning that they have adapted the charging infrastructure and the charging periods to their operations and to the power that was available. To my knowledge, there is no smart charging or scheduling of charging for different time periods. If you know more than I do, please share.
Can we?
Sorry, actually we took a bus, so
an electric
to come
one
from
or?
the airport. No. Just to. Yeah, to me, it's common sense that the buses, because they are in a depot by night, so it's common sense for them to use off-peak times, and for you as an grid operator to push them to use power by night.
Sure, it's common sense, but in all this range that ranges from dumb charging to smart charging to V2G, etc. There are various use cases and various constraints. In Monaco, we are lucky in two ways. First, there is no major constraints on the grid. I mean, we have quite a good capacity on the grid, on the grids. I would say both the low tension and the HTA1. And second, there is not a big amount of solar production in Monaco, and the pricing structure today of electricity in Monaco is the classical, peak and off-peak hours. So for this last thing, yes, I think they are focusing to charge during off-peak, but that is kind of coincidental, since anyway they were charging overnight the buses. So that's not a intended strategy or.
Yeah, maybe just shortly to integrate. During our study, we talked to several bus operators in Italy, and actually what they are, most of them are doing or going for overnight charging in the depot, so that is the classic strategy. Yeah. Milan, for example, said, but similar as Monaco, we have certain events, or it might be that a tube is going down and then our buses have to run more. In order to overcome that eventual critical point, they decided, even if in normal operation they are not needed, that they're going to put pantograph charging at the end of the line in order to make sure that even under heavy utilization they can reuse it. We saw, especially Torino, and again Milano, but as well Rome starts to thinking about, and we know some projects in Bolzano. Obviously, it is a surface, so probably you can get several megawatts of PV on the roof of that depots. Then the question is, do I use it? How can I use it? Do I put batteries on top? Do I use second life batteries of the buses? So I think there's a whole story to tell. And in a couple of years, we will see several technical solutions which are coming up. By now, it's mainly night charging, and that's it.
But I can testify the same. Mainly, it's night charging. Sometimes during non-peak hours during the day, they charge some buses because all the others are running, but some buses are in the depot. The only point is that nowadays they are just optimizing their missions. They are not optimizing the energy flow, in my view. I think we will get there, but now we are just convincing them to electrify. Let me say, okay. This is the
and
point
to reach
nowadays.
the full value of this, you need to either be an energy supplier or to work with an energy supplier that will be directly linked to energy markets to grab most value, because just off-peak and peak hours is the first step, but it doesn't allow for full monetization of smart charging or load switching.
But anyway, it's interesting, an application, for example, of an energy storage directly integrated in some movable charging points, because sometimes if you have a solar power production during the day, you can charge the storages directly, and the charging can be used during the night. And this is helping in some application also the layout of the depot, because sometimes you have some problems in the availability of charging points inside all over the depot. So this is an interesting application that has been studied in some application, especially for trucks more than for buses. Thank you. Thank you very much for your question. Are there other questions? Okay. So thank you very much. I think we can go. Thank you guys, and thank you all.